Hey guys, welcome back to another video. So here we'll be looking at probability questions, and for this one there's actually a whole lot of them that you need to learn. Now in this video I've actually included 7 worked exam style questions, and they all come from the GCSE and IGCSE recent syllabus. So let's have a look at what actually comes up here. Now on the list of topics I've got about 5 major things to work through here. Now when we say probability basics, this is just telling you how to sum up the probabilities and make it equal to 1. This is the common fact probability basics. Now you also got expected frequency. Now this is to do with finding the total number a certain event happens. And you can see a few examples there. I've also included a Venn diagram with probabilities and also the and or rules. Now for many people this is kind of a bit messy because it kind of links to tree diagrams. But I'll show you a very fast and unique way to actually get these done quick and easy. But yeah guys, let's have a look at the very first question right now. So Josh has 40 counters in a bag. In the bag there are 18 reds, 13 blues and 9 yellows. Okay, so we're going to keep this in mind, yeah? Josh puts some more red counters in the bag. Okay, so this is an important statement here. When you add more red counters, and we don't know how many, let's say now he has 18 reds plus an additional X counters, yeah? So that means in the bag he had 40 originally. Now he's got an additional X amount. The blue is still 13 and the yellows are still 9. So this is the total divided by this amount here, yeah? Now Josh is now going to take at random a counter from the bag. The probability that he will take a red counter is a half. So in other words, this means that if you're going to take a red, we know how many reds there are. There is 18 plus some extra X over 40 plus X, which is the total. And we know that this is equivalent to a half. Okay. Oh, this is a random one. Work out the probability that he will take a yellow counter. So we can work out what yellow is later. Let's go ahead and figure out what the value of X is, yeah? And once we have X, we'll know exactly how many counters are actually in the bag. And then we can work out the yellows. So solving this equation here, the easiest way to work through it is to firstly clear the fraction. In other words, multiply 40 plus X across and 2 across. If you do that, you're going to have 2 times 18 plus X equals 1 times, 40 plus X. Now, all you want to do here, guys, is literally expand the bracket. So both sides doing that, you can get 36 plus 2X equals 40 plus X. Now, moving the X's to the same to the left side and the non-X's to the right. So in other words, subtracting X, you're going to have 2X goes down to 1X. And subtracting 36 across, 40 goes down to 4. So X is 4. That means there were actually 4 more reds added on. So this means that the total of 40 should have been now 44. And the question was, work out the probability that he will take a yellow. We know we got 9 yellows, so it's going to be 9 out of 44. And that's the answer, guys. So there are 90 counters in a bag, alright? Each counter in the bag is either red or blue. We'll keep that in mind. So that the number of red counters to the number of blue counters to 13. Let's go ahead and work out how many counters we have straight away. So if you want to change this one into some sort of fraction, we can see that out of the total number of counters, let's say 15 pass, if you add them up, we can say that 2 out of 15 is red, and therefore 13 out of 15 must be blue. Now if you want to straight away work out how many counters there is, you literally just put in the calculator 2 over 15 times 90. And doing that, 2 over 15 multiplied by 90 will give us 12. So there are 12 red counters. For blue, same thing. 13 over 15 times 90. And that's going to give us 78. And of course, just double checking, adding these two, you get 90. So it checks out. Now let's keep going. So Lee is going to put some more red counters in the bag, so that the probability of taking at random a red counter from the bag is a third. Okay, so let's think about it a second, yeah? So you have 19 total. He's going to add some extra red counters, yeah? And you got 12 reds already. So it's going to be 12 plus some extra counters, let's say X. That means you now have 90 plus X in the bag, right? So this is going to be red counters, and this is going to be, and blue counters, well, is still 78. And here's the total. Okay. Now it says here that the probability of taking at random a red counter from the bag is a third. So this means that the probability of taking a red, and you know how many reds there are, you have 12 plus X over 90 plus X, and it's going to equal a third. Okay. Work out the number of red counters that Lee is going to put in the bag. Now, literally, you just have to solve this algebraic equation. The easiest way to solve this nicely is to literally multiply 90 plus x across and 3 across. So timesing 3 across and 90 plus x across, you can have 3 on the left side multiplied against 12 plus x. You can have 90 plus x on the right side multiplied by 1, which is, well, 90 plus x. So let's go and then expanding both sides. 3 times the bracket, you can get 36 plus 3x. The right side, 90 plus x. Now the tip is to always move all the x's on the left and all the non-x terms on the right. So moving plus x across, you're going to minus x. So 3x minus x is 2x. Moving plus 36 across, it becomes minus 36. So subtract 90 from 36, you're going to get 54. And finally, to get x, you got half it. So half of 54 is 27. So all the students in year 11 at a school must study at least one of geography, written by G, history H, and religious studies R. So in year 11, there are 65 students. Okay, so this looks like a Venn diagram problem. So we've got triple Venn diagram here. Now it says here that of these 65 students, we know that 15 study geography, history, and religious studies. So what that means is that you can put 15 bang in the center, because this is the common intersection between geography, history, and religious studies. We know that 21 study geography and history. So this means that you're talking about this interval right here. All of this must add up to 21. We've got 15 already, so there's 6 left that adds up to 21. 16 study geography and religious studies, so geography and R is over here. 15 plus 1 is 16. 30 study geography, so geography is the entire circle of geography. We got 30, so all of this must add up to 30, so we got 6 plus 15 plus 1, that is, I should know this, 22, so we got 8 left. So all of this adds up to 30. So that's always, guys, you just have to sum up carefully. Okay, next one, 18 study only religious studies. So careful with this terminology. You got 2 bits. You got only religious studies, and you got 37 study religious studies. When they use the word only, it means literally just this small segment here that doesn't include a geography or history. So just this region here, and that value is 18. And now we know that 37 study religious studies. So that means the whole circle must add up 37. So in your calculator, add up 18, 15, and 1. 18 plus 15 plus 1, that gives us 34. So that means a remainder of 3. So now we have 37. Okay, so now the Venn diagram is almost complete. So we're only missing our history segment and the outside segment. Now, just to be sure, we look back at the question, and at the top it says that all students in 11 must study at least one of the 3 subjects. So this means that this needs to be completely filled out. So the way to fill this out, we know there's a total of 65 students. So let's go ahead and add up all these figures, yeah? Let's see how many have been included. So when you do that, so I've already done this, you get 51 students, meaning that the remainder is going to be 14, okay? So 65 minus 51 to give us the remaining for only history. So now we know that all 65 students have been accounted for. We can say that there's been 0 outside the circle. So that's it. One thing to note, yeah, if you counted every single person here and now 65, you can never leave it blank. Because if you leave it blank, you'll lose the mark. That's the thing. Yep, it's a bit harsh, but that's how it is. But anyway, let's look at the next bit. So a student in year 11 who studies both history and religious studies. So we're talking about only people who study both. So we can see that 3 people study both and 15 study both. Of course, they study geography, but they still study both history and religious studies. Okay, so keep those 2 numbers in mind. We're going to ignore the rest. Work out the probability that this student does not study geography. So the people who do not study geography is, of course, these 3, because 15 of them also study geography. So the probability is therefore going to be the 3 people out of the total here, which is 18. And that's it. This is your answer. So Marcus plays 2 games of tennis. For each game, the probability that he wins is 0.35. Okay, so we know straight off the bat for every single game is 0.35 of winning. So literally write that down here. Now, this means that the probability of him not winning, in other words, losing, will be 0.65. Why? Because all probabilities must add up to 1. Okay, so that means the rest will be 0.65. Yeah, and that's it. That's 2 marks right there. Now B, work out the probability that Marcus wins at least one of the 2 games of tennis. So if he's going to win at least a game, that means he could either win the first game, then lose the second game, or lose the first game, then win the second game, or because this is at least, he could win both games because that's still at least winning a game. So we write down the probability options. So that's win the first game, lose second, lose the first, win the second, or win both games. And then you literally just find the probability. So this symbol I'm writing is a nice way of keeping track of what you're doing. So winning then losing, so that's 0.35 times 0.65. So 35 and 65. Losing will be 65 times 35, and winning both times will be 35 times 35. So when you work them all out, you then have to sum them up, yeah? So let's do it. So 0.35 times 0.65, that'll give you 0.2275. So you do that again here. And then last one, 0.35 times itself will be 0.1225. And then that means the total probability. So any of these 3 options can happen. So you have to add them up. So plus 0.2275 times 2. So that means the total probability of him winning at least game would be 5775. Yeah. So there are 12 bees in a bag. Now 7 out of the 12 are red, 3 out of the 12 are green, and finally 2 out of the 12 are yellow. So when you do probability questions, always make sure you note down the probabilities of every single possible scenario, like I did over here. This will literally help you guys for the later questions. Now, next bit. Lucy takes at random a bead from the bag and then keeps it. So that means the 12 will drop to 11. Then Julian takes at random a bead from the bag as well. Now work out the probability that they each take a yellow bead. Alright, so this is easy. So this is the probability of Lucy taking yellow first and then Julian taking yellow second. Now the probability of taking yellow first is, of course, you got 2 beads, so 2 out of 12. Now since Lucy keeps the bead, there's only 1 left, and you now got a total of 11 beads in the bag. And this is simple probability. You literally just put this in the calculator and you're going to get a simplified answer of 1 out of 66. Okay, done. B, work out the probability that the beads that they take are not the same color. Okay, so this is literally one of those combination questions, yeah? So we have to think about all the different combinations you can get. So for instance, you could firstly take, what colors we have again? So we've got red, green, yellow. So you could take a red bead first and then take a green second. Or you could take a red bead and then take yellow. And this can extend to other ones, yeah? You can take a green bead and then a red, or a green bead and then a yellow. And of course, you can also take a yellow first, then a red, and then a yellow first or a green. So you actually have 6 different probabilities. Now, thankfully, a lot of these you can see are repeated, like red and green, or green and red and yellow, yellow and red, or yellow and green, green, yellow. So naturally, you can just work out 3 of them and then double your answer to get the same amount. Now, to get red and green, so we'll do some of these in steps. So red, we got 7 out of 12. So we got 7 beads which are red. To get green, we got 3 of them, and there's 11 beads left altogether. To get red and yellow, again, red is 7 out of 12. And to get yellow, there's 2 yellows, and you've got 11 left, so 2 out of 11. So what I'm going to do, guys, I'll just do 3 of these, and then we're going to total them up and then double it. Now we did red and green, red and yellow. Let's do, which one is, yeah, green and yellow. That's the only one left. So to do green, yellow, for the greens, we got 3 out of 12 in the bag. And yellow, we got 2 out of 11 left. And that's it. So now in your calculator, put this inside, plus this result, plus this result. So, and once you do that, you must then double your answer by 2 to account for like the other ways of doing it. And when you do that, you'll get a final probability result of 41 out of 66. So a bowl contains n pieces of fruits. Of these, 4 are oranges and the rest are apples. Okay, so visually, to understand this, so we've got a bowl here, and we got 4 oranges. So let's say 4 oranges, and we can call that O. And we know that the difference between n and 4 are the remaining apples. So it'll be n minus 4 apples. Okay, so we're going to keep this right here. Now, two pieces of fruits are going to be taken at random. So you could either take one orange, one apple, or one apple, one orange, or two of oranges or two apples. Now, the probability that the bowl will then contain n minus 6 apples. So if you're going to get from n minus 4 to n minus 6, you would have taken two apples in a row. Because take one more, you get n minus 5. Take another one, n minus 6 left. And the probability of doing that gives you a third. So writing this as an equation, this means the probability of picking an apple and another apple is going to be, firstly, the first time you have n minus 4 out of a total of n times, and if you take an apple, you're going to be left with n minus 5, and of course, you got one less fruit, so n minus 1, and all of this will give us a total probability of a third. And that's it, guys. This is the equation to work with. If you're able to follow this step, then all you have to worry about now is the algebra. Now, how to evaluate this easily? My tip is to literally just follow my steps here. So all we have to do, guys, is multiply the top half, so n minus 4 times n minus 5, just leaving a bracket for now. And then n times n minus 1, you can stick them together. And what we're going to do, we're going to clear the fraction. So we're going to multiply these two bottom values across and 3 to the left. So times in 3 across, it will appear here. Times in n and n minus 1 across, it will be here. 1 times these lot is the same thing. And now all we're going to do is fully expand these lot. So on the left hand side, we're going to leave the 3 out. We're going to do n times n, which is n squared. So this is like a quadratic. N times minus 5 is minus 5n. Minus 4 times n is minus 4n. So combine them will be minus 9n's. Minus 4 times minus 5 is plus 20. And on the right side, expanding the bracket, you're going to have n squared minus n. And of course, times them by 3, you can have 3n squared minus 9 times 3, 27n plus 60 equals the right hand side. Okay, so if you look at this carefully, this is actually in the form of a quadratic. Let's move n squared and minus n to the left hand side. So we need to subtract n squared and plus n. So this is going to give us 2n squared, and plusing n, it'll go up to minus 26n plus 60, and now we're going to have 0. Now you could go ahead and use a quadratic formula, or you can make your life easy, because you'll realize that all of these values are in the 2 times table. So half the equation, you can get n squared minus 13n plus 30 equals 0. You could use a formula, quadratic formula, no problem, or you could actually just factorize it, because this is actually, you're actually able to factorize it. We need to look at two numbers that multiply to make 30, and we know straight off the head that's going to be 3 and 10. And we can notice that these two numbers, 3 and 10, you can subtract them from each other to get minus 13. So it'll be n minus 3 and n minus 10. This means that when n minus 3 equals 0, n has to be 3. When n minus 10 equals 0, n has to be positive 10. And that's it, guys. It's going to be one of these values. Now the question is, which is it? So apparently you got 4 fruits and you have n altogether, so it can't be n equals 3 because you already have enough oranges. So the answer must be n equals 10. So there are only 3 white and 5 black counters in box X, whereas in box Y you have 4 whites and 3 blacks. Okay, let's keep this in mind, yeah? Now Michael takes at random 2 counters from box X, so any of these two, puts them in box Y. He then takes 1 random counter from box Y and puts it into X. Okay, work out the probability that there is now an equal number of white counters and black counters in box Y. Ooh, okay, so this kind of question is all about counting carefully, yeah? So let's have a look. So let's see possible ways of getting exactly the same number of whites and blacks in Y. So if you have to take 2 counters from here, let's say we took 2 blacks, yeah, and put them into here. You're now going to get 5 blacks and 4 whites. And then you can take 1 black back. So then you have 4 and 4. So we can say, alright, you can say Michael could firstly we'll take 2 blacks first in box X, meaning you're going to have 5, and then Michael can then take 1 black and put it back in X. So that's one option. So that could be in terms of probabilities. So X is out of 8 by the way initially, and this is out of 7. So let's just do the maths here. So taking 1 black first, you have 5 already. So 5 out of 8 times, now you have 4 out of 7 left in box X. And in box 7, you now have technically 9. So now you have, it's kind of hard to imagine. So you got 2 blacks already here. So you got now 5 blacks and 4 whites. If you can take a black and put it back, you have a 5 out of 9 chance of picking a black. So this is one example. There are more combinations, by the way, guys, and the idea is to work out every single combination and then work them out and then add them up, the probabilities. So let's find another combo. So let's see. So okay, so suppose we take whites now, yeah. What you could do, you could take a black and a white. So now you have 5 whites and 4 blacks, and you take a white back, and you got 4 and 4 again. So that's it. So you can take a black and a white, making it 5 and 4, and taking a white back. You could also do it in this way as well. You can also take a white first and then a black, and then give white back. So these two are going to give you the same answers, by the way, yeah. So these are the same. So if you work one out, you work the other. Is there any other combinations? What if you took 2 whites? If you put 2 whites here, you're going to get 6. Nope, no chance. So you can't choose white. So these are your results. Now all you want to do is just put some probability values on them, yeah. So probability choosing a black first, you got 5 out of 8 again, and now you got 7 left. Probability choosing a white, you got 3 out of 7. And now if you put this in this box, you now technically have, I have to count this carefully, so you got an extra black and an extra white now, yeah. So this means we now have to choose a white, you got 5 out of 9, yeah, remaining. Is that right? Yep. And this will be the same as above. Now, yeah, now all you want to do, guys, is literally just calculate these probabilities and then total them up. So let's do each one, yeah, step by step. Okay, so when you put this in the calculator, you should get 25 out of 126. By the way, guys, I think this is correct, and I haven't checked this, so I would like to hear your answers for this. And the second one below, let me just change that 4 to a 3. Yep, and you should get 25 out of 168. And again, the bottom one will also be 25 out of 168. Now all you do is literally add all these up, and you should get a total probability underneath, and then you get a total probability of 125 over 252, which is, by the way, in terms of in terms of decimal, it's about 0.496, so roughly 50%. Nice, you got half chance.